Hello friends, welcome you all. So today we will see some simplification on CFG context-free grammar, and I have listed here four different types of simplifications. So when we are simplifying some grammar, then we can remove some useless symbol from that grammar. We can remove some useless productions from the grammar, or we can remove from epsilon productions from the grammar, or we can remove some unit production from the grammar. And after simplification, the grammar becomes simple, and some complexity of grammar can be removed by the simplification. So all these four types of simplifications we will discuss here. And one thing I must tell you, see, the useless symbol and useless productions, generally, these two simplifications are done simultaneously. If we are removing some variable, then all productions for that variable that will also be removed. So these two are done simultaneously, and then we will discuss one process of unit production removal and process of epsilon production removal. So these we will discuss one by one. So I will start with useless symbol and useless productions. As you know, friend, grammar belongs to some particular language. Grammar generates some particular language, and this grammar is used to create all strings of that particular language. And in strings of any particular language, you will have always terminal symbols. There will no variable in the strings of language. So now, based on that, we can divide the variables of grammar in two different categories. One that are participating in generating the final strings of the language, or some variable may be there that are not participating in the final string generation for that particular language. So how do you identify whether some variable is participating in the generation of final string or not? So to identify this, you can see all the production. So for example, I have taken this grammar here, and you can see here how many productions are in this grammar. 1, 2, 3, 4, 5, 6, 7. 7 productions are there in this grammar, and we have four different variables in this grammar. So we have four different variables in this grammar. Now you can see, my friend, this particular grammar has having 7 productions and 4 different variables. Now we need to identify which variable or terminals are useless, so we can remove them, or we can remove some productions also. So how to identify the useless production and useless symbols, so that we will discuss now. So we start with S. So you can see, my friend, S is having two productions here. S is having two productions here. One is S gives A B small d, and other is S gives small d. So now, if S is generating in one production of S, it is generating the string of terminals only. So which is S gives D. So that means S may participate in the final string generation. So that particular variable you can consider as generating. It is generating variable. Now you can see, my friend, all productions of A are having variable in the right hand side. So you can see A gives small a, capital A gives B. So this is not generating any string of terminals only. That means it cannot participate in the generation of final string of the language. So what we can consider A, we can consider as A as non-generating symbol, non-generating variable. So I can write here non-generating. So A is non-generating variable. Similarly, with B, you can see we have only one production of B, in which there is one variable in the right hand side. So this also does not generate any string that is only having terminals. So you can consider this B also as non-generating symbols. Now you can see C is having two productions here. C gives small e C and C gives F. That means C is generating one production where there is only terminal. There is only terminal, which is C gives F. That means it may participate in the generation of string of the grammar. So I can consider it as generating. So now we have identified the two types of variables here in this grammar. So you can see generating and non-generating. So now, as we have identified non-generating variable, so we can simply remove all these non-generating variables from here. Now, if I remove A and B from this particular grammar, all productions of A and B will also be removed. So you can see how we would be doing. So friends, now if I remove these non-generating variables from this grammar and all its production, then the grammar will be see in this particular production if we remove A and B. So this will be the S gives the D will be remaining, and there is again one more production there which is giving D only. So I will add S gives a D only once. So I have removed this. So it becomes S gives a D, and one more production is there, S gives a D. So we will not remove the same production again. So I will use only S gives a D. Now if we are removing A, so all these productions of A and B will also be removed from this grammar. So after removal of non-generating variables, this grammar will be like this. C gives small e, capital C and F. Now after removing non-generating variables from this grammar, the grammar becomes like this. Now can we apply some more criteria to further simplify this grammar? Yes, we can. Now, we will apply one more criteria there, one more criteria as reachability. As reachability. Now, on the basis of this, again we can divide the variables of grammar in two different categories. One is reachable, another is non-reachable. Now, what do you mean by reachable variable? So, if from a starting from a star symbol, if you can reach particular variable using all production, then this would be reachable variable. If you cannot reach any particular variable starting from star symbol, then this particular variable will be non-reachable. So you can see, my friend, here if I apply this criteria, so S is a star symbol. S is a star symbol in the original grammar also. So now S will always be reachable. A star symbol is always reachable. So S is, as it is a star symbol, so it is always reachable. Now in this particular grammar, after removing A and B, in this particular grammar we have only two variables. One is S, other is C. So out of these two, S is reachable. Now C is reachable or not. So starting from S, using all possible production, we cannot reach C because there is only one production, S gives D, and in any production of S there is no C, right? So this particular variable is not reachable, unreachable. It is unreachable variable. Starting from initial symbol or start variable, we cannot reach C. So we can simply remove all unreachable variables and their productions from the grammar. So now S is reachable, C is unreachable. So we will remove C and all its production. So now finally this grammar becomes S gives D only. So finally this grammar becomes as gives D. So now you can understand original grammar was this. Then we have applied two criteria there. First is generation criteria we have used. So in using generation criteria, we divided the variables of grammar in two different categories. One is generating and other is non-generating. So we removed all non-generating variables and its production from the grammar. Then we applied one more criteria, reachability. So based on that criteria, we again divided the variables in two different categories. One is reachable category and the other is unreachable category. So again, we can remove all unreachable variable and its productions from the grammar. So after applying both the criteria, we finally get the grammar as gives a D only. So you can see, my friend, we have removed three variables from the grammar and four terminals from the grammar. One is capital small a, small b, small e, small f. These four terminals we have removed, and capital A, capital B, capital C. These three variables we have removed from the grammar. So that means this grammar can generate only one string, which is D. Now I will take another way of simplification, removal of unit production, and then we will discuss removal of epsilon production. So now friends, now we will discuss the removal of unit production. So first of all, you must know what do you mean by unit production. So suppose some production, if there are some productions like A gives B, A gives B, where we have only one symbol which is variable in the both side, in left hand side and right hand side. So here we have only one symbol in both the side and it is variable. So one variable is generating other. One variable is generating other. Now suppose this particular variable which is at right hand side of this production again is generating some variables like some terminal or variables this like this. So now you can see we are generating B from A, then B is generating a small e and C, and this D. Now this these two are terminals, string of terminals only. Now you can see here, if A is generating B, then B is generating two different string here. E gives C, E, C, and D. Now, here we can apply transitive property. So now A is generating B A is generating B and B is generating D, E, C, and or D. So we can simply remove this intermediate state and we can directly generate EC from A, EC and D from A. So this is how we can simply remove the unit production, and this is a very simple method of removing unit production. So I hope it would be clear to all of you. Now we will discuss removal of epsilon productions from the grammar. This is only possible when the epsilon is not a valid string for your grammar. If your grammar is generating epsilon, then you cannot remove all epsilon production from the grammar. You will have at least one epsilon production there. In case your grammar is not generating epsilon and still there are some epsilon production, then you can remove all epsilon production. So how to identify whether any grammar is generating epsilon or not, so that we will see. Now I will take one example grammar here, like as gives AB, D, and then D. Then A gives A, epsilon. B gives B, epsilon. Now, suppose this is the given grammar. Now, you can see here, we have six different person here in this grammar, and star symbol is s. Now you can see both the production of s, both the production of s. So this particular these two productions are generating abd and d. Now suppose a and b both are generating epsilon. So if we replace both A and B in this particular production, so this will become as gives a D, as gives a D. So that means using this production, we cannot generate epsilon. And now we consider this production. So with this production also, we cannot generate epsilon. We cannot generate epsilon. That your star symbol is not generating epsilon, then it means your grammar is not generating epsilon. Your grammar is not generating epsilon, or the epsilon is not a valid string from this grammar, for this grammar. Now, if epsilon is not valid string from this grammar, now then we can remove all epsilon productions from this grammar. We can create equivalent grammar which is having no epsilon production. So now we have identified this grammar is not generating epsilon. So now we will see how to remove epsilon productions from this grammar. See, there are two epsilon productions which are A gives epsilon and B gives epsilon. B gives epsilon. Now what we will do, we will consider one production at a time. So first we will consider A gives epsilon. So now what you can do, so to remove A gives epsilon, see all the productions where we have A in right hand side. We have A in right hand side. So here we have two productions where we have A in right hand side. So one is as gives ABD and other is A gives small a e. Now just replace right hand side A with epsilon, right hand side A with epsilon, and whatever string is remaining there, generate one more production with that string for the particular variable. So now if I replace A with epsilon here, so it becomes as gives BD, as gives BD. So as gives BD is not there, so generate one production for S with BD. Now this production, now consider this production. So it is A gives A small a capital A. So if I replace this right hand side A with epsilon, so it becomes capital A gives small a, so which is not there. So you can add one more production here, a small capital A gives small a. So now these two productions were there only, so we have considered this. So now simply we can remove A gives epsilon from the grammar. So now we have completed this. Now we will consider this production. We need to remove now B gives epsilon. So search all the production where B is at right hand side of the production. So we have now three production where B is having right, B is there in right hand side. So one is as gives A, B, D, and other is BD, and one more production is there, B gives small b, B. So now these three productions are there where B is having, where we are having B in right hand side. So now one by one we will replace B with epsilon in each production. So if I replace B with epsilon in this production, so it becomes as gives AD, as gives AD, so which is not there in this list. So I can create one more production with as gives AD, as gives AD. Now if I replace B with epsilon in this production, so it becomes as gives D, as gives D. So as gives D is already there, as gives D is already there, so we will not add one more production with the same terminal. Now if we remove, if we replace B here with epsilon, so it becomes capital B gives a small b, which is not there in this original grammar. So I can add one more production here like this. So now we have considered all productions. So now we have removed B gives epsilon also. So now after removal of A gives epsilon and B gives epsilon, the grammar is like this. So we have now how many productions we have? We have four productions of S, two productions of A, and two productions of B. Now, after removal of epsilon production, this grammar is epsilon production free grammar. And this particular grammar can also generate all the strings that original grammar can generate. So this is how you can remove epsilon productions from the grammar. So I hope it would be very much clear to all of you. And if you have still any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.